Good morning everyone. Welcome to the next lecture of cloud computing. In this lecture we will talk about the NIST cloud computing reference architecture. So basically NIST has given a reference architecture for cloud computing paradigm. It talks about various actors and their key responsibilities, various layers in cloud computing, and the kind of technical things which are supposed to be implemented by these different layers. So let us see what is there into this cloud computing reference architecture. So it is a reference architecture. It defines a template description of the architecture at different levels of abstraction. It is a highly abstract model which shows different functionalities at different levels, and the lower level shows different methods to perform specific tasks in cloud computing service paradigm. This architecture is vendor neutral. Any cloud service provider may use this architecture. It is not dependent on a specific cloud service provider, and different cloud service providers, they may use different technical solutions to be implemented in different layers of cloud reference architecture. It is a conceptual model which discusses the technical requirements and different operations of cloud computing. It is acting as a blueprint which guides developers for the design of cloud computing services and different applications. So what does it mean by a blueprint? It is a composition of interconnected services implementing reusable logic for building applications, list of different functions and their APIs, and description of their interactions. So what are the different cloud service deployment models? We know that there are 4 cloud service deployment models. So this cloud infrastructure may be operated as a public, private, community or hybrid cloud. So when we say it is a public cloud, it means that the same infrastructure is used by many different cloud consumers over the public network such as internet. Private cloud is a cloud which provides services to specific consumers and which is hosted within a particular organization or by some hosting company. Community cloud is a cloud which is created by many organizations which are having the similar kind of interest or concerns. Hybrid cloud is a combination of more than one type of cloud. So in case of hybrid cloud, storage as a service may be implemented as a public cloud service, while infrastructure as a service may be implemented as a private cloud service, or it could be any other type of combination of any two types of or more types of cloud. So the differences are based on how these different computing resources are provisioned to different cloud consumers. So this NIST model defines different actors, means the users who are playing the role in this cloud computing paradigm. And it also defines the roles and the responsibilities of these different actors. So actor could be a core user, it could be an individual or it could be any organization, and which are having the key responsibilities in the functioning of the cloud computing services. While the architectural components for cloud services are defined for deployment, service orchestration, service management, service security, and privacy. So what are the different actors and their roles? Actor could be a individual or it could be any organization with some key responsibilities. Mainly two kinds of actors are involved. One is the consumer, another is the cloud service provider. So cloud service provider is the organization or individual who is actually providing the cloud services, and cloud consumer is the user who is actually acquiring and uses all these different types of cloud services provided by the cloud service provider. Then we have other types of actors like broker. So broker is intermediate between the cloud service consumer and cloud service provider, and this broker could be any organization or it could be some individual. They try to hide the complexity of the different services, and sometimes they create new services for different cloud consumers. Auditor is the independent person who is there to do audit of performance, security, and assessment of different kind of cloud services. Carrier provides connectivity and transport of data and services between cloud service providers and consumers. So this diagram is actually showing a conceptual model of cloud computing reference architecture in which all these different actors and their key responsibilities are listed. For example, cloud auditor has the responsibility of security audit, privacy impact audit, performance audit. Cloud broker is there to perform service intermediation, service aggregation, service arbitrage, and cloud service provider has the key responsibilities such as service orchestration, cloud service management, resource abstraction and control layer, and at the bottom we see the horizontal bar showing the cloud carrier. We see that security and privacy, they are acting as a vertical stack, vertical layers, because security and privacy is applicable to each and every layer inside this cloud computing reference model. So cloud consumer can browse the service catalog which is provided by cloud service provider. It may request service depending upon the usage scenarios and the activities they perform. Then they may set up some service contract with the cloud service provider stating about different parameters for the cloud services. The cloud consumer may be billed for the service. If we talk about the SaaS consumers, they may be billed on the number of users, time of use, net bandwidth, storage volume, like that. For IaaS and PaaS consumers, they may be billed according to the processing, storage, network resources, number of virtual machines, number of HTTP calls, number of IP addresses used, storage volume, and other parameters. Usually the consumers sign SLAs to specify their performance requirement which is supposed to be fulfilled by the cloud service provider. However, sometime or in most of the cases, these SLAs are offered by cloud service provider, and most of the time they are not negotiable between the cloud service provider and cloud service consumer. So what are the SLAs? SLA stands for service level agreements. So these are the contracts which are negotiated and agreed between cloud service provider and consumers so as to locate and reserve resources to satisfy consumers' requirement with efficiency and optimal resource and service usage. So whenever the consumers are accessing cloud services provided by any cloud service provider, they are actually expecting the quality of the services. So quality service parameters are indicated in this SLA, which are supposed to be met, which are supposed to be fulfilled by any cloud service provider. So SLAs are there to guaranteed and agreed SLA, and later on, in case of any dispute between the cloud service provider and cloud service consumer, auditor may be there to measure and monitor relevant metrics for any cloud service. So different SLA models must be considered for IaaS, PaaS and SaaS, because these different service deployment models are having different set of requirements. So SLAs can be defined clearly for infrastructure as a service. What kind of hardware resources are actually needed by any cloud consumer. For platform as a service and software as a service, still it is very difficult to define SLAs, and still they are very vague, because they refer to very high level of functionality. But sometimes they can be agreed between the provider and the customer based upon their business requirements. Let us see one example of SLA for infrastructure as a service. So we know that in case of infrastructure as a service, the hardware resources are made available or provisioned to the cloud consumers. So there could be parameters in the SLAs like this: CPU capacity, what is the CPU speed for virtual machines, memory size, cache memory size for virtual machine, boot time, the time for virtual machine to be ready for use, storage, size of data, scale up, maximum number of virtual machines for one user that can be made available, scale down, minimum number of virtual machines for one user that would be available, scale up time, the time to increase the number of virtual machines, scale down time, the time to decrease number of virtual machines, availability, uptime of service in a specific time. So this is one of the examples possible for SLA, which is for infrastructure as a service. So we see that there are different types of cloud services. In case of SaaS consumer, the cloud service could be for CRM, for sales, for billing, for ERP, for human resources, content management, financials, collaboration, document management, email, etc. For PaaS consumers, it could be for application deployment, development and testing, integration of applications, database, business intelligence. For infrastructure as a service consumer, it could be for storage, service management, platform hosting, for computation, for backup and recovery. So what are the key responsibilities of a cloud service provider? Cloud service provider is there who is actually managing the computing infrastructure behind the cloud services. So cloud service provider runs the cloud software, and he usually makes the service available to interested parties. He is there to make arrangement or sign contract with the cloud service consumers. Cloud providers may also provide a list of SLAs. SLAs talk about the promises which the cloud service provider will do to its consumers. It also talks about the different limitations and obligations that the customer or the consumer is supposed to accept. Cloud service provider also provides its pricing policy, and in most of the cases the SLAs which are listed by the cloud service provider, they are not negotiable between the consumer and the provider. So these are the key responsibilities of cloud service provider, such as service deployment, service orchestration, cloud services management, security and privacy. So if we look at the scope of control between the cloud service provider and cloud consumer at different levels, if we talk about the application layer, so end user applications and services are used by SaaS consumers, but actually they are installed and managed by PaaS consumers and SaaS providers. If we talk about the middleware layer or virtual machine layer, it provides building blocks for application development used by PaaS consumers, but installed, managed and maintained by PaaS providers, okay, and which is hidden from the SaaS consumers. If we talk about the OS layer, so operating system, virtual machines and drivers, they are hidden from SaaS and PaaS consumers, and they are controlled by infrastructure as a service cloud service provider, but they are used by infrastructure as a service consumers. So an infrastructure as a service provider may allow multiple operating systems to be installed as different virtual machines. Now, what is the scope of control in case of SaaS, PaaS and IaaS? So, in case of software as a service, the consumers will have only a limited administrative control over the applications and cloud services. In case of PaaS, the cloud service provider is managing the infrastructure behind the services, and the cloud service provider provides tools for the deployment and development of different applications. The consumer does not have any control over the application, and the consumer will have a limited or sometimes no access to the infrastructure available, which is managed by the cloud service provider, such as the operating system, storage devices, device drivers, servers. In case of the infrastructure as a service, the cloud service provider acquires the physical resources and runs the software to make these available to the IaaS, PaaS and SaaS consumers through virtual machines. So in this infrastructure as a service, the cloud consumers will have control over the virtual software components like operating system and network. So if you look at the scope of control between the provider and the consumer at different layers, this diagram depicts that. So if we talk about from the point of view of cloud consumer, so in case of the SaaS, the cloud consumer will have access to different applications. The cloud consumer will not have access to have control over the virtual machines, operating systems, etc. In case of platform as a service, the cloud consumer will have a control up to this middleware layer starting from the application layer. In case of the infrastructure as a service, the cloud consumer will have control through all these layers. If we talk about the scope of control from the cloud service provider point of view, so in case of the infrastructure as a service, the cloud service provider will have a control up to this operating system layer. In case of the middleware layer, in case of PaaS, the cloud service provider will have a control up to this middleware layer. In case of SaaS, the cloud service provider will have a control up to this application layer starting from the operating system layer. Thank you.